Hi, we're going to see how you don't need to be an expert in geometry to solve situations by applying the theorems, and we're going to talk specifically today about circles and arcs. But I think that this idea works for any geometric situation that involves applying a theorem. And what is a situation that applies a theorem? Is that any situation in which you have to apply any theorem to solve it. So actually you don't need to remember all the theorems, just get it into a flashcard or on your notes, and using your notes and using the theorems you may solve any situation. We're going to see examples today about circles and arcs, and I hope that you get the idea and notice that it is not so difficult to do it. Okay, so let's start. We're going to start seeing an example, and this is the example. Imagine that we have a circle here. We draw a circle, we have two chords in the circle, and using these chords I have here an angle of 60 degrees. And the question is, what is the angle BAD, the central angle? What is the central angle BAD? Okay, so the question is, what is BAD? Okay, the angle BAD. Let's say that this is the question. So the first thing you have to do is to remember what to apply. What will be the theorem I can apply, such as I can find the angle BAD. So what do we need? What we need is a theorem that relates this angle with this angle. Okay? And remember that for case of circles, what you need to know about the concepts is that the central angle is related to the measure of the arc. So if you know how to relate the measure of the arc or the measure of the central angle with the inscribed angle, so you can have an answer. Now I just wanted to see the theorems. So I have here theorems about circles and arcs. We have here about congruent central angles and arcs. So I don't have inscribed angles, I don't need it. Here I have a relation between central angles and congruent chords. I don't need that because I need inscribed angles. I have here another theorem about congruent chords and congruent arcs. I don't need this theorem because I need inscribed arcs, inscribed angles. Here I have a theorem about chords and diameters. No, again, chords and diameters. And here I have a relationship between inscribed angle theorem. Look at. So as I have the inscribed angle theorem, it means that this is the situation I can solve, or this is the theorem I can use to solve the situation. So let's see what says the inscribed angle theorem. It says that if I have the measure of the angle B, I mean this, okay, so it's going to be a half of the measure of the arc. A half of the measure of the arc. So the central angle is going to be a half of the measure, the inscribed angle is a half of the arc. But remember that in this case, the arc is referring to the central angle, so it will be the same, a half of the measure of the central angle. So what we just have to do is to check here, what is the inscribed angle? 60, and we need to know the inscribed angle. So now we're going to find what is the inscribed angle. So we know that measure of angle, in this case is angle C, measure of angle C equals a half of the measure of the arc. So which arc are we talking about? We're talking about the arc BD. So BD. Okay, this is what we're talking about. That the measure of the angle C is a half of measure of BD. And the measure of the angle C is 60. So 60, okay, I'm sorry for the numbers, is equal to a half of measure of the angle BD, but we don't know what is BD. We know that is equal to the central angle A, but let's write measure of BD. So it means that the arc is just multiplying by 2. So 2 times 60, 120 degrees. If I multiply by 2 of the equation, it's going to be the measure of the angle BD of the arc BD. Okay, and this arc is the same as the angle, the central angle. So the angle A, measure of the angle A is just 120. Okay, and this is what I use. What did I use? I used just the theorem. I found what is the theorem that works for me, and then I found the situation. Okay, let's see another example. Let's say that we're going to change, we're going to set another point here, another point here, and we're going to set a quadrilateral here. Okay, so we have a quadrilateral, and the idea is to find what is angle E, what is angle B, what is angle D. Okay, and we have here 60 degrees, and let's say that this angle is 40. Okay, I'm not using like the appropriate values. I'm just wanted to show you the information, so you don't need like to know all the values, but this could be the angles. Okay, and we need to know angle E and angle B. So let's say that now we want to know, so what is angle B and angle E. Okay, so as we need to know what is angle B and angle E, and if we have no idea or we have no experience about geometry and these theorems, we just need to know what to do and check the theorems. Okay, so go to the theorems, let's see, inscribe angle, and look at that. Here we have a quadrilateral inscribed in a circle, so it means that we just need to read, and it says the opposite angles of a quadrilateral inscribed in a circle are supplementary. So what does it mean? That these angles are supplementary. So if this is 60, that will be 180 degrees minus 60 Okay, 180 degrees minus 60, and this will be 180 degrees minus 40. And then I just apply the theorem to find the solution of the situation. Okay? As you notice, I'm just checking the theorems and using the theorems, finding what works for me. Now let's see a final exercise to see how to use the theorems. Let's say that we don't need this quadrilateral anymore. So by okay. We don't need the quadrilateral anymore. No, we just need the circle. Okay, we just have the circle, and now we're going to have a tangent here. So tangent. Okay, a tangent to a circle here. Gotta set a point. Let's set a point here. Let's put a tangent to this point. Ouch. Tangent. Yes, here is the tangent. We need to set a point here. Point. Okay, now tangent. Chin, point, and tangent. Okay, we have the tangent here, and we're going to set a chord to this tangent. So point of tangency, and let me do a chord. Okay, that's the idea. And we're going to see that this angle here is 130 degrees. Okay, so the angle you can see here, this angle is 130 degrees. This is easy to measure. This angle is easy to measure. And the question is, what is this arc? What is the arc? DE. DE. What is the arc? DE. Okay? So the question is, we don't need this anymore. Okay, so the question is, what is, okay, what is the arc DE? What is the arc DE? Okay, excuse the handwriting. Okay, what is the arc DE? So, okay, I need a tangent, I have an angle, so I need an arc using the tangent and the angle. So I'm going to my theorems. Let's see the theorems. Look at this theorem, look at here. And it says the measure of an angle formed by a tangent and a chord is half the measure of the intercepted arc. Okay, I have the tangent, I have a chord, and it's a half of the intercepted arc. Look at here, I have BC, this option, or this option. So look in here, I have the tangent, the angle, and I need to find this arc. So I just need to use the expression. It says measure of angle C. In this case, the angle is D. So measure of angle D equal, and it says a half of the measure of the arc BDC. So a half of the measure, in this case, the arc is DE. So, okay, a half of the measure of DE. Okay, and the angle D is 130 equal a half of MDE. I just need to multiply the equation by 2, easy peasy. So it will be 260 degrees equal measure of the arc DE. Okay, and we found the solution. We just need to set what is the theorem that we need, and after you know what is the theorem you're using, then you have the answer. So my hint is that every time you have a geometry situation, just have like a list of theorems and working so hard on checking what are the theorems you need. Okay, so my hint, have your list of theorems by topics. For example, we have this topic that is chords and arcs, and you can have another list of theorems about circles, another list of theorems about triangles, and it doesn't matter. You just need to check what is the best option for you. In this case, it was circles and arcs, but it could be anything. Okay, and I hope that you enjoyed the video, and I hope that you start working on geometry. Geometry is cool when you understand that you need to follow just a bunch of rules and a bunch of theorems. Okay, hope that you enjoyed this video, and thanks for watching. Comment, share, tell me what we need to improve here, and tell me what we can do about that. And see you next class. Bye. Goodbye.